Hi, I'd like to show you a system we have developed for building distributed applications. It's called Visual Obliq and consists of an interface builder and runtime support to distribute computation.
The primary goal of the project is to make it as easy to build a distributed, multi-user application as it is to build a single-user application using state-of-the-art tools. Watch now as we use Visual Obliq to build a simple but non-trivial distributed multi-user application. Starting with an empty workspace, I'll add a form widget, and I'll resize it to make it a little bit bigger. Next, I'll come back to the palette of widgets and click on the text widget. I'll position and size this one also. When I double-click on a widget, an attribute sheet appears. Here, I'll change the value of the text widget to be Hello Visual Obliq. And I'll also make the font a little bit bigger. When I click on the Apply button, these changes all take effect. Now, to make this a little bit more interesting application, I'll add a file browser and also a text editor. I'll double-click on the file browser to bring up its attribute sheet, and I want to change its name to be just the letter F. I'm also going to add some callback code. This code, written in the Obliq programming language, is invoked when the user specifies a file name in the widget. The callback is simple. First, let n equal self.f.getFileName. This assigns the specified file name to the variable n. As we shall explore in more detail later, in Visual Obliq there can be multiple instances of each form. Self is used within a callback to refer to the instance where the callback occurred. Self.f refers to the widget called f within that form, and getFileName is a method of a file browser, and it returns the name that was selected. The line let t equal local.loadFile of n causes the contents of the file given by the variable n to be loaded into the variable t. And finally, self.edit.putText of t stores the contents of variable t, remember that's the contents of the file, into a widget whose name is edit. We'll hit apply to make these changes happen. And the last thing we need to do is to change the name of the text editor to be simply edit. Done. Go back to the GUI builder, hit the run button, and a few seconds later, right about now, the application appears. The file browser lets us select a file name. We'll pick the file about circ, and in the text editor, we can do whatever editing we'd like to do. Let's now convert our application into a distributed one in order to allow multiple sites to share the editor. First, I'll delete the Hello Visual Obliq banner and also the file browser. Next, I'll give the form a name, MUE. The shared editor will work as follows. After each keystroke, we'll retrieve the entire contents of the editor where the user just typed and store this text into the text editor widget of all the instances of the application. The callback for the text editor is as follows. Let t equal self.edit.getText. This retrieves the text. For each m in MUE, do. This loops through all of the instances of the form named MUE. m.edit.putText of t. This statement stores the text at the widget named edit at each instance. Our application also needs a mechanism to invite other users to join in. I'll add a type-in widget to let the user specify a site where there's another potential participant. I'll call the type-in W, and the callback for it is a two-liner. Let site equal self.w.getText. This retrieves the text from the type-in field. Install at of site. This calls a built-in procedure, install at, to invite the user at some site to join the session. If the user agrees, Visual Obliq sends code to that site, causing a copy of the shared editor to be created there. The editor as it stands now does not have any floor control policy. Every time any user enters a character, it appears at all sites. Adding rudimentary floor control is easy. I'll have a grab button that a user must click in order to get control of the floor. And I'll also have a status message informing all the sites of the user who has the floor. The status message is a piece of text. The name of this widget is Message, MSG. I'll change the font to be big so you can read it on the video. And I'll also give it an initial value of floor with nobody. The grab button will have a label called grab with an exclamation mark. And its callback is as follows. For each M in MUE, do m.message.putText floor with, and we'll concatenate that with the host name. So this will cause the status message in all of the instances to be updated. If m is not self, then m.edit.makePassive. All the instances other than the one where the user clicked the grab button will become passive. Else, m.edit.makeActive. So the site where the user clicked on the grab button is the only one that becomes active. Oops, typo. There we go. Okay, and this is the entire application. We can run this application by going back to the Visual Obliq application builder and hitting the Run button. Now I'll hit the grab button. You can see that I'm on the machine called Castle. Hi, Mom. I am on Castle. I'd now like to invite Krishna to join in this editor. Krishna is at a site called Magician, and the inset video is showing Krishna's screen right now. I guess he's looking at the Circ homepage through Mosaic. I'll invite him right now, and a window pops up on his machine, and it says, "You are invited to a session of multi-editor." Hopefully, Krishna will accept our invitation by clicking on the green Accept button. This causes the application to migrate to his machine. Since I still have the floor, I'll ask Krishna if he wants to go to lunch. Want to go to lunch? Let's see. Now, Krishna has grabbed the floor. You can see the floors with Magician, and he's suggesting that we go to Gordon Biersch in 15 minutes. Well, that sounds pretty good, so I better finish up this video. I hope that the video has given you a feel for how easy and fun it is to build distributed multi-user applications using Visual Obliq.